So now it's time to discuss homogeneity in terms of physics. What is the meaning of the term homogeneous? To be homogeneous is to be identical, and with respect to physics we use this in equations. So if we have a look at what makes up an equation, we are having a left-hand side, a right-hand side, and those quantities are separated by an equal sign. And what that actually means is that whatever we've got on the left-hand side is equal to whatever we've got on the right-hand side. In mathematics, it is generally just about the values. So that would be a correct equation. 20 is equal to 20. However, in physics, since we're applying the values to quantities, to things that can actually be measured, the units make a difference too. So if we just take a look at this, where we're starting off with a correct equation, but then just add different units, so this states 20 meters and this is 20 seconds, then that equation is no longer true. So for an equation to be correct in physics, we need two criteria. First, we need the values to be equal to one another. However, we also need the units to be equal to one another too. We generally discuss homogeneity in terms of base units in physics. The main reason for this is if we consider such an equation, F equals ma, the units on the left-hand side are the Newton. The units on the right-hand side are the kilogram and meter per second squared. And unless you follow the previous videos, just by looking at this, one would think that the units on the left-hand side do not equal the units on the right-hand side, and hence one might conclude that this equation is not homogeneous in terms of its units. However, we know that Newton is a derived unit and it's got a special name. So basically we do know that the Newton is there representing all of these units. However, if we're given an incorrect equation, so just change mass for, say, velocity, and we end up with F is equal to VA, the units on the left-hand side are still the Newton, whilst the units on the right-hand side are meter per second and meter per second squared, giving us meter squared per seconds cubed. Now, if you've never come across this before, you wouldn't be able to tell if that equation is homogeneous in terms of units or not. So what we generally do is stick to base units, convert every unit that we've got in terms of its base units, and see whether the base units match up between the left-hand side and the right-hand side. If they do, then the equation is said to be homogeneous. Is it enough for the equation to be correct? No. Remember that for an equation to be correct, it must also be homogeneous, identical in terms of the actual numbers. But in physics, most of the time, we're just checking for the units.